Physics, Newton's laws, P22K define momentum and describe examples of momentum in collisions. We're looking at the situation when a skateboarder is standing on top of the ramp, is not moving anywhere. So that means the object is not moving, it has no velocity. Now momentum as a formula is calculates the product, you multiply mass times velocity. So momentum equals mass times velocity is the relationship between mass and velocity. Mass being measured in kilograms and velocity being measured in meters per second. Momentum is measured in kilograms times meters per second. If the object is not moving, that means the skater is not moving. The skater has no velocity, that means the skater will have no momentum. Because if the velocity is zero, in this equation, everything else becomes zero. This is the triangle. P stands for momentum. Momentum P goes on the top of the triangle. Mass stands for M. Velocity stands for V. They'll go on the bottom of the triangle. This in case it helps you to remember the formula better. The second diagram, the skateboarder is already moving down the ramp. Now, if we know the mass of the skateboarder, and if we know the velocity of the skateboarder, because it's already moving down the ramp, in this situation we can calculate the momentum of this skateboarder. So if the object is moving, that means the object will have a velocity, and momentum can be calculated. We also need to know the mass, how heavy the moving object is, the skater in this situation, in this case. Okay, momentum can be easily described in collisions. Collisions can be analyzed through momentum. We have two balls, the pink and the green. They're moving towards each other. Pink with a velocity v1, green with a velocity v2, and then they collide, they interact, they crash one into another. But because they are elastic, they're going to bounce off. Pink is moving away with the velocity v1 and the green is moving away with the velocity v2. So we see they kept their velocity just moving backwards where they came from. So momentum equals mass times velocity. We can calculate the momentum of the pink one. We can calculate the momentum of the v of the green one if you know the mass and we know the velocity. The objects bounce off. This is called an elastic collision because the objects bounce off. They're not changing their shape, they're not breaking, they're not sticking together. Momentum is not increasing and is not decreasing because of elastic collisions. This is the law of conservation of momentum. Next, define momentum and describe examples of momentum in collisions. Momentum equals mass times velocity. And now in this situation, this is the situation of a crash where, for example, two cars, we see they deform, they change their shape, the objects stick together. This is called an inelastic collision. Remember previously when the objects bounced off was called an elastic collision. This is called an inelastic collision. Momentum still is not changing. So the law of conservation of momentum is still valid. That means using the formula I can calculate momentum before and after these collisions. But there is energy lost. So these cars are losing energy because the result of the collisions is mostly heat. Well, think about rubbing your hands together. That's a collision that generates heat. But we're not going more into depth into this right now. Here we can consider an example of a comparison of elastic and inelastic collisions. If objects bounce off, that's an elastic collision. Like for example, let this be like a tennis ball or a ping pong ball, a rubber ball anyway that's bouncing off where it came from. And then the second situation, in inelastic collision, let's say you're throwing down a tomato. So you're throwing down a tomato or an apple and gonna hit the ground. It's gonna stick there. It's not gonna bounce back off because in this situation, this is an inelastic collision as the objects stick together. It sticks together to the surface. Okay. Now we said that if an object is moving, the object will have a velocity. That means the object will have a momentum. Now, This skateboarder being on top of this ramp, this skateboarder doesn't have a momentum because its velocity is zero, it's not moving. Now, if we're looking at the energy of the skateboarder, if I'm calculating the energy of the skateboarder, the energy of motion, the kinetic energy of the skateboarder, is going to be calculated through the formula mass times velocity. Now you see this part is exactly identical to momentum, just we're going to have a square for velocity, so it's going to be velocity squared, and everything will be divided by 2. So the difference between momentum and kinetic energy is that part of the formulas are the same, just the kinetic energy gets a fraction line divided by 2, and it has a square for velocity. So kinetic energy is measured in joules. If the object is not moving, kinetic is coming from Greek kinetikos, which means motion. If the object is not moving, the object has no velocity. Now, if I'm looking in this formula for kinetic energy, if it has no velocity, the whole thing becomes zero. That means the whole thing, kinetic energy becomes zero. So that means if the object is not moving, the object has no velocity. That means the object has no kinetic energy. Now the skater is down the ramp. Now going back to compare momentum and kinetic energy. Momentum, if the object is moving, it has a velocity. I can calculate its momentum. Now if the object is moving, again it has a velocity. That means this whole equation is not zero anymore, so I can calculate a kinetic energy. So if the object is moving, it has a velocity. I can calculate how much energy will this object have because of its motion, because it's moving. Obviously, we also need to know the mass, or how heavy the object is, the moving object is, which is the skater in this case. So if I know the mass and if I know the velocity of an object like our skater, I can calculate the momentum, and I can also calculate the kinetic energy that that specific skater has. So kinetic energy is calculated, look at moving ball's mass times velocity squared over 2. So it's related to an object in motion. So kinetic energy is related to an object in motion. Now if we look here, if we have a baseball and we have a basketball, they're both moving at the same velocity. Now because the basketball has a larger mass than the baseball, the kinetic energy of the basketball will be much, much larger than the kinetic energy of the baseball, which also means that if your kinetic energy is larger, it's going to be much harder to stop the basketball compared to stopping the baseball. So this is momentum and this is kinetic energy, two concepts that can be calculated using almost the same formula.